Dear student, once again, all of you are welcome to my YouTube channel, Maths Success Point, and I am discussing the topic relation and function today, as I have uploaded a number of videos related with the relation and function, inverse trigonometrical function, as well as continuity and differentiation. But once again, I am going to prepare the video for your welfare, for the student who are just going to take the admission in class 12 and they are going to prepare for class 12, and so that in the year 25 you will prepare nicely and you will expect the 100% marks in mathematics. But thing is that, dear student, it is very easy to say, but it is very difficult to do the work. It is my sincere advice to all of you that you must have to prepare since very beginning. Don't wait that we will start our study during November, December or January. No, you start since very beginning. And a number of times I have given the good suggestion to you that in mathematics you must have to prepare first of all the definition, formula, as well as the concept related with the topic which you are going to start. Then you practice the simple questions. Once you know the process, by doing the practice of simple questions, you go to difficult. And in mathematics, difficult questions are not difficult, but that is the combination of simple questions. You split the difficult question into simple question, and simple questions already you solve that there will not be any problem to find out the solution of the difficult question. That is why I am going to request you that you must have to study, practice time and again. And related with this topic, relation and function, which whose videos I have posted a number of times. I have given the definition of different types of relation: empty relation, universal relation, reflexive relation, symmetric relation, as well as the transitive relation. You go through, you see properly my videos and try to understand the concept, then you start the solution of the question which I am going to give you today. Because I told you, without the definition, without formula, it is very difficult to understand the questions. Okay, and it is my request to all of you, you like my videos and share my videos, subscribe my channel so that I shall be motivated and I will do better work for your welfare. I shall motivate you, okay, at every step. But thing should be in your mind that I will secure 100% marks in mathematics, because I will give you the help so that you will secure 100% marks in mathematics. Okay, let me review the basic thing, then I will start the solution of the questions which are given in the NCERT book. Okay, let me draw the diagram first. Small diagram I am just going to prepare. Dear student, you see, suppose I am going to take the three elements of the set A, 1, A, B and C. Okay, I am going to take A here, B here and C here. Similarly, these are the elements of the set A. Similarly, we will take the elements of the set A on the vertical line A, B, C. I am going to draw the diagram so that you will understand easily. What is reflexive relation? What is symmetric and what is transitive? As I told you, I have given already. I have uploaded the videos for your welfare. But I am just reviewing the things before giving the solution of more and more questions to you. You see. And you think that on x-axis this is A and A. Here will be A and B. Then here will be A and B. Here will be A and C. You see, the pair of ordered pairs I am just going to prepare. Okay? And here it is B. First of all you take B and then A. Here also you take B and B and B and C. You take C and A, C and B, and C and C. All the three relations you can learn by this diagram. Okay? As I have given the detail for these relations in my previous videos, that is why you see that one. I am just going to explain over here. I am just going to draw a diagonal. So this is the diagonal. This is the diagonal I am going to draw. You see, this is a diagonal. And my dear student, you see carefully this diagonal. First thing is reflexive relation. First, reflexive. Reflexive. Reflexive relation. Reflexive means you see elements A, B and C. That is why A, B, B, C, C must belong to A. Relation. What is the relation? Relation, that we write here the relation. Relation you see. Relation, all the ordered pairs you write. That is first is A, and next is AB, next is AC, and you write BA and BB and BC, next CA and CB and then CC. That is a relation, and it is also known as, you have studied in class 11, A cross A. A cross A. In the Cartesian product of the elements of two sets, like that. And this is a relation. Reflexive means same elements. A, B, B, C, C should belong to this relation. You see, A, B, B, C, C. Okay? Then it is reflexive. You can write here A. You write A, comma A, B, comma B. And C, comma C belongs to R. All these belongs to R. And you can write separately also. A belongs to R, B belongs to R, C belongs to R. But condition is here for all elements must belongs to A. My dear student, you must have to write this thing. Otherwise, the marks will be deducted while your evaluation will be there by the teachers. A, B, C belongs to A. Half marks will be there for this. Then relation is symmetric, and you see A, B, B, C, C lie on the diagonal. That is why it is reflection. R is reflection. Reflection. For the beginners, I am going to review it. R is reflection. You can write is reflection. R is reflection. I am going to write it clearly. I think it is not really visible to you. R is reflection. Second case. Symmetric. 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 How the relation will be symmetric? You see. Relation is symmetric. Symmetric means I will give you one thing, a very important example. You see, I am taking, you seems to be it is a one page. You see, it is one page. But no, it is, there are two pages. There are two pages because they have the same length and breadth. That is why you see this is the half portion is upper portion, half portion is lower portion. If this is half portion, you will take over the second half portion with respect to this line diagonal. Then this portion will cover to this. Okay? Same distance. You see the mirror and you see your face. Mirror, that is the axis. From the mirror, you are the object. From the mirror, the distance of the object will be equal to the distance of the image and mirror. Same thing, same distance. That is why object and image are symmetrical to each other with respect to the mirror. Very good example. Similarly, you see AB. See, dear student, AB belongs to R. You see, AB is here, AB is here. So you see, this is AB. And BA, you see, this is BA, implies that AB belongs to R, BA also belongs to R. For all, B belongs to A. See carefully, AB belongs to R, TA also belongs to R. Same distance, that is why these are symmetric. You see the distance of this one and this one, both that is same. Not only this thing, you see AC is here, CA is here. Distance will be same. BC is here and CB is here. You see distance will be same. That is why these are symmetrical. Similarly, you can write not only this thing, each and every case you must write, which is in the relation. As I have taken AB, you see BC. BC belongs to R, implies that CB also belongs to R. CB, you see, CB is there. This is the CB. CB is here. BC, CB. And AB, BA I have taken. You take AC. AC belongs to R, implies that CA also belongs to R. You see. CA also belongs to R. Everything is here. That is why what you will say? R is symmetric. R is symmetric. Very, very simple. I am just going to review. As already I have posted. You see this thing. R is symmetric. This relation is symmetric. Only one relation left. I am going to take. I am just also going to review that one also. That is why you see carefully, my dear student. I am reviewing because you will not be able to understand the questions. For the beginners, I am taking number 3rd is transitive relation. Transitive relation, you see, that is very important. Okay? You see, A, B belongs to R. See carefully. And next, I am taking one more thing. A, B, B, C. A, B, this pair ended at B. Another pair you take which starts with B. Okay? Implies that this backwards belongs to R. This belongs to R. It belongs to R. Implies that. This implies that. Then what will happen? First and the last element of both the pairs will be A, C also belongs to R. But condition is there for all A, B, C must belong to A. Otherwise that will not be true. Okay? That belongs to A. See carefully. That is why see AB, BC. AC belongs to R. For all ABC belongs to A. You can say that R is transitive. R is transitive. This condition also must hold. Then only you can say that the relation that is reflexive, symmetric as well as transitive. Okay, I have explained everything. If the relation is reflexive, symmetric, transitive, definitely it will be equivalence relation. That is why R is a equivalence relation. And it is also known as the universal relation. As you have seen the universal set in class 11, in the set theory. Similarly, universal relation. If there is a universal relation, definitely it will be reflexive, symmetric and transitive, and you can say that it will be the equivalence relation. That is why it is equivalence relation. Okay? And let me take the question. I think I have reviewed the things and you must have to use this diagram. Simply you will understand. Let me take some questions related with the relation and function from NCERT book and exercise 1.1. My dear student, as I am advising you that you must have to do the work, practice time and again, so that you will be able to understand the questions, different types of questions. Let me take, you also can keep the NCERT book with you so that you will understand what is given and what is required. Determine question 1. You will take first part, I will take first. Determine whether of the following relations are reflexive. As I have told you, reflexive. This is reflexive, symmetric, symmetric, this is symmetric, and transitive, Then what is the relation? See the relation. I am going to write R, relation R in the set. You can write relation R in the set. Relation R in the set. Set I am taking. You must have to keep in mind the set. That is 1, 2, 3, and so on up to 14. Up to 14. These are the elements of set A. And defined by the relation. What is the relation? Defined by R. R is equal to, you see, R X and Y, such that X, Y, you see. And what is the relation? This relation you must have to use. 3x minus y is equal to 0. For R, for the relation you must have to use this condition. Under this condition, you will have to see the solution. And you will have to see whether the relation is reflexive, symmetric and transitive. These three relations you must have to check whether these are hold or not. Let me write the relation first of all. As I told you, student, you must have to keep in mind this condition. Without this condition, you cannot write the relation. Elements of A, 1 to 14, you can use. Okay. Then what will be? See, let me take x. First of all, you will write the value of x. X is 1. I am going to write over here 3x will be equal to y. Use this one. 3x minus y is equal to 0 means 3x is equal to y. Okay. Let me take, if x is equal to 1, 3 into 1, 3. Y will be 2. See carefully. Next, x is equal to 2, then y will be equal to what? In place of x, you write 2 into 2, 6. It will be 6. Okay. But the elements do not exceed the element of A. You must have to keep in mind. If x is equal to 3, suppose, in place of x, you write 3, what will be the value of y? 3 into 3, 9. And x is equal to 4, suppose. In place of x, you write 4, 12. Yes, that will do. 12 is there. 12 is here. 4. Next, 5. Because 5 is also there. 15. 15 is not there. That is why you can't go beyond this one. That will be the relation. As I told you, you must have to form the relation first of all as per the condition which is given over here. Okay? This is the relation. And you must check whether this is reflexive. First case. I told you already that reflexive. That is why I have reviewed the thing. So you must know the definition of reflexive, symmetric and transitive. You see, my dear student, 1, 2, 3, 4, 5 up to 14 elements are given. That is why 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and so on. 14, 14 must belong to R. But these are not here. Let me take only one. If you want to write all, you can write. See, 1, 1, 2, 2, 3, 3. You see, R not here. कोई भी एलिमेंट इसमें नहीं है. इनमें से कोई भी एलिमेंट नहीं है. Then what you will say? Does not belong to R. Similarly, you can write 3, 3 because there will be a big line. 4, 4, 5, 5, 6, 6, 7, 7 up to 14, 14. Each and everything does not belong to R. 4 all, 1, 2, 3 and so on belongs to A. As I told you, my dear student, you can write all the elements. I didn't write because there will be a big line. That is why R is not, therefore R is not reflection. Wrote reflection. R is not reflection. एक ही पेयर लेने से पता लग जाएगा 1, 1 यहाँ पर नहीं है. That is why it is not reflexive. You take one, and if you want to take a big line, you can take that. That is up to you. Let me take the symmetric condition. Symmetric. Whether this given relation is symmetric or not. Okay. My dear student, already I told you. You see, 1, 3. 1 3 belongs to R. What should happen? 3 1 also belongs to R. You see whether it is there. 1 3 belongs to R, but 3 1 is not there. 3 1 is not there. Does not belong to R. Only one condition is sufficient. एक condition काफी है इसको prove करने के लिए. But you must have to prove it by using R. अब बाकी लेना चाहते हैं तो बाकी भी ले लीजिए. 1 3 is not here. Okay? If 1 3 is not here, then what will happen for all? Condition you must write. 1 and 3 belongs to A. It is not symmetric. As I told you, you can take 2 6. 2 6 belongs to R. Implies that 6 2 does not belong to R. Similarly, 3 9 belongs to R. 3 9. As I told you, if you want to take 9 3 does not belong to R. Similarly, you take 4 12. 4 12 belongs to R and 12 4 does not belong to R. For all 1 2 3 4 5. For all you can type for all 1 2 4. You can write the elements which are given only here. You can write 4 4 12 3 9 like that. All belongs to A. These are the answers. That is why it is not symmetric. R is not symmetric. You write R is not symmetric. It is not a symmetric relation. Okay, let me go to for what? Third relation. That is transitive relation. Let me take the transitive relation. My dear student, you see the condition. As per the condition, I think automatically you will understand. Transitive. Transitive third case. Transitive relation. Transitive. Okay, see. I will take only one condition related with this relation. 1 3 belongs to as I told you in the condition. 1 3. This pair ending at 3. You take next pair which starts from 3. 3 9 belongs to R. ये भी है. Implies that first and last. You see 1 9. Whether it belongs to R, 1 9 is not there. That is why it does not belong to R. For all 1 3 9 belongs to A. What does it mean? 1 3 belongs to R, 3 9 belongs to R. That 1 9 does not belong to R. It is not a transitive relation. R is not transitive. Transitive. You see, it is not a transitive relation. Then what does it mean? What you will say? R is neither reflexive nor symmetric nor transitive. Therefore, hence, my dear student, you will write R is neither reflexive nor symmetric and nor transitive. That is a very, very important question. You see carefully, try to understand the thing, so that there will not be the problem to find out the solution of the different types of questions which are given in the NCERT book. I have told you the detail of this question. Let me take some more questions from the NCERT book, and so that you will be benefited. Okay, let me take the another question. Second part of it. Second part. What will be the second part? You see. Next case. My dear student, you must have to see, check the things and try to understand the question as I have given over here, and you will be able to understand the things. Okay, let me take the next part of it, which is from the NCERT book. Let me remove the thing. Second part you will see similar kind of thing you will have to check in this. Second part means second question. Second part of question number 1. But it is also just like a question. Same thing you will have to see question number 1 second part. What is given? You see the relation only. I am going to write, but that is your natural number. Relation R in the set. Relation R in the set N, and that is natural number of natural number. Natural numbers. Natural numbers defined by what? Defined relation. Defined by the relation R. R is, you see, similar kind of thing is given x, y, such that. But relation is given y is equal to x plus y. Y is equal to x plus y, and but thing is that x is less than 4. A very simple question is given. You see, question is very simple. Check the things. Let me take. You will have to form, complete the relation R. What will be the order pairs with R? But you must have to keep in mind this condition you will have to use for y. Y is equal to x plus y. But the things, the value of x will be equal to what? Less than 4. But less than 4 means take the natural number. Natural numbers will be up to 1 only. 1, 2, 3. 1, 2, 3. 3 natural numbers you can take. 0, that is a whole number. 0 will not come because here it is given set of natural numbers. Okay? Here it is given set of natural numbers. That is why it will be 1, 2, 3, 4. Okay, let me take. If x is equal to 1 is the natural number, y is equal to 6, you will say. Next, you see, x is equal to 2, y will be how much? 7, you put 2, 7. X will be 3, you put 3, that will be 8. More, these will be the pairs of it. Other elements you can note because under condition x less than 4. Under this condition and this condition, both the conditions you must have to apply. And for the relation, this is the relation. Let me take whether it is reflexive. First case, reflexive. Very simple. I told you what the natural numbers you have taken in the set. 1, 2, 3. 1, 2, 3. If you want to take, you can take the set. Natural numbers belongs to n. That will be, let me write here 1, 2 and 3. 1, 2 and 3 belongs to n, natural number. Okay? As for this one, I have formed this relation. You see, 1, 2, 3, this belongs to n. Or n is equal to 1, 2, 3 only. If in place of n you want to take a, you can take. That depends upon you. I have taken n so that you will understand this is natural. Okay. But you tell me 1, 1 is here, 2, 2 is here, 3, 3 is here. No. These are not here. That is why it is not reflection. You see, 1, 1 does not belong to R. 2, 2 does not belong to R. I can write in one line, but I am writing separately so that you will understand. And 3, 3 also does not belong to R. For all because I have taken the set 1, 2, 3 belongs to n, natural number. So that you will understand. Okay? That is why you see this thing. Therefore R is not what? It is not reflection. Then for symmetric. For symmetric relation, what does it mean? If 1 6 belongs to R, then 6 1 also belongs to R. It is not here, you see. It is not here. If 1 6 belongs to R, implies that 6 1 also belongs to R. But it is not here. That is why it does not belong to R. Then what you will say? R is not symmetric. Very simple. In each and every question I am telling you the same thing. R is not symmetric. Let me take transitive relation. Transitive, I am taking here the transitive relation. Transitive. Relation transitive, third case. Whether it is transitive or not. Let me take. My dear student, I have told you in detail the transitive. Let me take suppose C. A, B and C belongs to what? N, natural. Okay? Then what should happen? A, B belongs to R. Relation I told you. Okay? And next, BC must belong to R. Implies that AC must belong to R. Is it happen here? कोई भी एलिमेंट नहीं है. 1 6 यहाँ पे नहीं होगा, 6 से स्टार्ट होने वाला कोई नहीं है यहाँ पर. 2 7 ले लीजिए, 2 7 7 से स्टार्ट होने वाला नहीं है. 3 8 ले लीजिए, 8 से स्टार्ट होने वाला नहीं है. दैट इज व्हाई आई हैव गिवन दिस कंडीशन. नो वन कंडीशन इज देयर हियर. ओके, आई एम राइटिंग 1 6 belongs to what? R and 6 6 3 whatever it may be, 6 3 and 1 3, there is no error. Actually it is not convenient to write over here because only 1 6 is here, other elements are not here. That is why I have given this condition and I can say that R is what? Not transitive. R is not transitive. My dear student, like that you can explain the things which are very very important. Let me take one more question so that you will be understanding the concept of the questions. Let me take one more question. Let me take the third part of it. Third part I am taking of question number 1. Third part you see. Similar kind of question is there. Similar kind. Third part, my dear student, you see. R is a relation. Relation R in the set. Relation R in the set A. Set A you see. Carefully you see. 1, 2, 3, 4, 5, 6. These are the elements of A. And R is equal to what? R is equal to C X Y, such that Y is divisible by X. Y is divisible by X. This is the condition. Under condition is given. Y is divisible by X. That is why you see Y is divisible by X. Whether your condition will hold or not, okay, you must have to see the case. In the third case, which is very very important, and you will have to form the relation first. R. Different pairs of R will be equal to R as per the condition. Okay, solution. Concentrate over here. R will be equal to what? See, you must have followed this condition. Elements you take from here. 1 to 6 elements are here. X may be 1, Y may be 1, because Y is divisible. 1 is divisible by 1, and then 1 and 2 will be there. 2 is Y. 2 is divisible by 1. 1 3 also may be there. 1 4 may be there. 1 5 may be there. 1 6. You see, this is x and this is y. Y is divisible by x. See, I am following the condition. You see. Next what will be, because this is over. 2 x is 2 and 4. 2 and 2 may be there. In place of y also there will be 2 and 4, 2 and 6, not more than 6 you will get. These are the elements 2 6. Okay, then 3 x and y. 3 is divisible by 3. Next we take 3 and 6 may be there. Y is divisible by, and next will be 4 may be there, but there will not be the other. 4 may be there. 5 may be there. 5 divisible by 5. 6 may be there, divisible by 5. That is the relation, and these are the ordered pairs of the relation. By using these pairs, you must have to prove first is reflexive relation. Reflexive relation, I told you already. For the reflexive relation, what does it mean? 1 1 2 2 3 3 4 4 5 5 6 6 must belong to R. All are here. Under this condition, you must have to form the relation. You must have to keep in mind the important thing. As I told you, first to remember the formula, concept, definition, then you come to find out the solution of the question. Otherwise, it will be very difficult to get the solution of the question. Okay, you see 1 1. Let me write all the things. 1 1, 2 2. I am not going to make it lengthy. And 4 4, and 5 5, and 6 6. All belongs to R. For all, 1 2 3 4 5 6 belongs to A. All belongs to R. That is why R is reflexive. R is reflexive. Note 2. That is identification. 1 1 2 2. That lies on the diagonal line. While you will draw the diagram for this one. On x-axis you write all the elements. On y-axis also you write the element. You will get the diagram. You can do it. Okay. Next is number 2. Symmetric. Symmetric relation you will have to prove. R will be symmetric. See whether it is symmetric or not. See, for each and everything, you see 1 1, the second element is 1. You start next pair 1 and 2 you can take like that. 1 1 belongs to R. Okay, and symmetric. Let me take 1 1 because 1 1 belongs to 1 1. There will not be the problem because 1 1 2 2 3 3 4 4 5 5 6 6 6 relation, that will be the equivalence relation. That is reflexive, symmetric and transitive. All three relations will be there in 1 1 2 2 3 3 4 5 5 5 6 6. Very important point I am telling you. That will be the equivalence relation. Let me take another thing. That will be, first of all, let me take 1 2. 1 2 belongs to R. Let me take, implies that for symmetric relation 2 1 also belongs to R. You see 2 1 is there or not? 1 2 is here, but 2 1 is not there. Only 1 is sufficient. 1 2 belongs to R, 2 1 does not belong to R. My dear student, it is reflexive but not symmetric. For all 1 2 belongs to A. R is not symmetric. R is not symmetric. Only one condition is more than sufficient. R is not symmetric. You see, it is reflective but not symmetric. Let me take the transitive. Third case, transitive. Transitive relation. Okay, let me take 1 4. Same thing. If you want to take 1 4, you can take 1 4, and then any condition you can take. 1 3 3 6 1 6 1 6 is here. Yes, Let me take any element you can take. See, 1, 2 belongs to R. 1, 2 is here. Let me take next element. 1, 2. 2, 2 is here. Or 2, 4 you can take. 1, 2. Next 2 से start होने वाला element लीजिए. 2, 4 belongs to R, implies that first and last 1, 4 must also belong to R, then it will be transitive otherwise. 1, 4 is there? Yes, 1, 4 is there. Not only this one, you can take the other things. Not only 1, 2. You take 1, 3. 1, 3 belongs to R. And next, you take the element which starts from 3, 3, 6 belongs to R. Implies that first and last 1, 6 must also belongs to R. You see, whether it is here or not, 1, 6 is there? Yes, 1, 6 is there. You can see each and every element that must follow the condition. For all 1, 3, 6 belongs to A. Here also 1, 2, 4. For all 1, 2, 4 belongs to A. You can take the other things so that the function will be transitive. My dear student, you also can take 1, 5 and you take next which starts from 5. 1, 5, 5, 5. 1, 5 is there. Yes, it is transitive. You can take this one also. 1, 5 belongs to R. You see the condition, my dear student, I am taking 5, 5. 5, 5 is belongs to R. You see, next pair you take which starts from 5. Then first and last 1, 5. 1, 5 belongs to R. You see 1, 5 is there. For all 1, 5 belongs to A. Then what does it mean? R is transitive. R is reflexive. R is transitive but not symmetric. R is transitive. Right? Write the thing. R is transitive. I am going to write over here the answer. What will be the answer of this question? What will be the answer? R is transitive. R is transitive. That is why you see. Hence, what you will say the answer? R is reflexive. As we have proved, reflexive, transitive, but not symmetric. That is not symmetrical. It is not symmetrical. See carefully the things. It is symmetrical. Okay? That is a symmetrical relation. Similarly, you can take the other examples which are very important for you. Let me take some more questions which are very important for you. Okay? I am taking the very important question, my dear student, you see, which is very, very important for you. I have told you the 3 questions related with the exercise NCERT book 1. Let me take one more question for you, which is very, very important, or the important part of this one. This thing you will see. R is question number 1, 4th part. Let me take. R is relation R in the set. Relation R in the set Z. That is integer, set of integers of all. See carefully, my dear student. Set of integers. Because under the condition you can solve the question. Defined as R. What is R? R will be equal to X and Y. So that X minus Y, difference of both the integers is an integer. You must know the definition of integer. Okay? Very important question I am going to discuss with you. That is why dear student, you see the solution of it. What will be the solution? Different things you will see. X minus y is an integer. The difference should be integer. Then what should happen? What will be the relation? Let me take. For first relation is reflexive relation. See reflexive. Let me write reflexive. Reflexive. What is the reflexive? Let x belongs to integer z. Integer. Okay? A little technical question is there. That is why try to understand. Then what should happen? X must belong to what? R relation. In place of y you take. Because what will be their difference? Using this condition, x minus y will be integer. And you must know it belongs to R. X minus x will be equal to 0 is an integer. Like that we will have to prove. Because their difference is integer. X for all x. You can write for all x belongs to what? Z. I have given already. Then what you will say? R is reflexive. R is reflexive. Okay? You see, my dear student, next. Second case of it, try to understand symmetric. This is the technical, a little technical, because numerical values are not. I am taking the only value. You see, x is 1, 1. 1 minus 1, 2, 2. 2 minus 2, 0. 3, 3. Like that. You can take 1, 1 belongs to R. 2, 2 belongs to R if you want to take the numerical value. Then what will happen? So, 1 minus 1 is equal to 0. And 2 minus 2 is equal to 0. Integer. It is integer. That is also integer. Integer. Everywhere 1, 1, 2, 2, 3, 3. Whatever you want to take, you can take. Similarly, you take. Suppose x, y belongs to what? Z. Integer. X, y integer. Then what will happen? X minus y belongs to what? R. For all, as I have given already, x, y belongs to Z. You can take any two integers. That depends upon you. And you must have to prove that their difference means like that. I am going to check it. X and y. You write it here. Okay? X and y. Then what will happen? And I am going to write it the same line so that you will understand properly. Okay? X, y belongs to R. Implies that yx also belongs to R. For all x, y belongs to Z. What does it mean? X minus y. Under the condition is given here, x minus y. Okay? Let me take. Suppose I am going to take the example. What example? X minus y. It is what? The difference between two. Because these are integer. Difference of two integers, that will be integer. You must have to put in mind. Is integer. And next thing you take y minus x, also integer. Integer. Let me take one example. Okay. Suppose 1, 2. 1, 2 belongs to R. That implies that 2, 1 also belongs to R. 1, 2 belongs to R. Then 2, 1 also belongs to R. Okay. Then you must have to see. If it belongs to R, then what will happen? Under the condition 1 minus 2 is equal to minus 1 is an integer. I am just taking so that you will understand. Is an integer. You say here you take 2 minus 1, that is 1 is an integer. I am taking the example so that you will understand. I have taken the integers in the form of x, y. And I have taken in the numerical form also. You can take an integer 2, 3. 2 minus 3, it will be equal to minus 1. Minus 1 is integer. That is why the relation is symmetric. R is symmetric. R is symmetric. R is a symmetric relation. Similarly, let me take one more thing for what? Transitive relation. Okay, let me take for transitive relation. For the same question, which is a very, very important question, my dear student, and you must have to see it. It is transitive relation. This is a transitive relation, which is a very, very important third case. Transitive relation. Transitive. How you will say it must be transitive? Same thing. X, Y, Z belongs to Z. This is capital Z. These are the integers. I have denoted here. Then what will happen? X, Y belongs to R. See carefully, my dear student. Y, Z belongs to R. Implies that what will happen? X, Z must also belong to R. X, Z also belongs to R. 4, X, Y, Z belongs to what? Integer. You see under the condition, what is the condition? Their difference should be integer. See, X minus Y, I am taking plus Y minus Z. You see, Y will be cancelled by Y. X minus Z. This is integer. You see, X and Z should be integer. This is integer. Is integer. The difference is that is integer. I have taken by the condition this one. X, Y is integer, Y, Z is integer. The difference X, Z belongs to be integer. Similarly, I am taking suppose the numerical value. 2 is integer, 3 integer belongs to R, and 3 and 4. 3 is integer, 4 is integer belongs to R. 2 and 4. 2 and 4, these are also integer. Because 2, 3, 4 belongs to Z. These are integers. And if you want to take the difference of it, 2 minus 3. You see, 2 minus 3 is equal to what? Minus 1. Is integer. And 3 minus 4 is equal to minus 1. Integer is integer. As per the condition, which is given over here. As per the condition, you will have to see. Next 4. 2 minus 4 is equal to minus 2 is an integer. Then what you will say? What you will say? R is transitive. Therefore, R is transitive. R is transitive. My dear student, I think you got the point. My main objective is that you must understand the relation reflexive, symmetric and transitive. If the relation is reflexive, symmetric and transitive, it will be the equivalence relation. That question generally asked in different type of competitive examination as well as in the CBSE examination. That is why you must be aware of that one. As per the condition, you must have to solve the questions. That is why it is my sincere advice to all of you. You like my channel, you like my video and share my videos and subscribe my channel so that I shall give you more and more solution of the questions in future. Also, I think let me stop over here, otherwise your video will be very lengthy. Other questions I will discuss with you for my next video. Thank you to all of you.